Along with scientific notation, we also need to look at numbers and understand significant figures. Significant figures are very important to the physics course as they help us assign a degree of precision to our answers and our calculations. If there's a stopwatch reading of 3.2 seconds, this is written to two significant figures. Now, if I had a stopwatch which was more precise than that, maybe the reading would say 3.23 seconds, and you can see that this is to three significant figures rather than two significant figures, so it's a lot more precise. In our course, you will probably have to give your answers to two significant figures or three significant figures, or if the examiner is looking for a certain number of significant figures, it will be given to you and you'll have to give it to that many number of significant figures. So let's look at the number that we had previously again, which was 1.98 times 10 to the power of 8. And we were talking about watt, although the units are not important right now. But if you have 1.98 times 10 to the power of 8, you can see that 1.98, that's three significant figures. Now, if I wanted to write this to two significant figures, then I would take the third significant figure and round it up. In this case, when I round up the 8 to the 9 also rounds up to become a 0. So I end up with 2.0 times 10 to the power of 8, and that would be to two significant figures. If I wanted to write this number to one significant figure, then I would remove the 0.0 and I would just have 2 times 10 to the power of 8. And that would give me precision to one significant figure. So there are certain rules to what makes significant figures significant. We've got a number, the first number is 504. So you can see that the number of significant figures are three significant figures. And the reason is that in an integer, all the digits count as long as the last digit is not 0. So in this case, the last digit is not 0. So 504, all three digits count. So this would be three significant figures. And if I wanted to write this in terms of scientific notation, I would write 5.04 times 10 to the power of 2. Now, the second number, which is 608,000, you can see that this is also three significant figures because I've got 608. And then I have zeros at the end. So the zeros do not count to the number of significant figures. So I have three significant figures. And in terms of scientific notation, I would write this as 6.08 times 10 to the power of 5. Now, if you look at the next number, it's a decimal number and it's 0.000305. And this is also to three significant figures. This is because those zeros before the number do not count. So we're looking at the number which is 305. We have three significant figures. And if you wanted to write this in terms of scientific notation, I would write 3.05 times 10 to the minus 4, moving the decimal place towards the left. Now, if you look at the last number, it's 0.005905. So in this case, again, after the decimal, we've got two zeros. These zeros do not count towards the significant figures. Then I have the number 5905, which are four significant figures. And if I wanted to write in terms of scientific notation, I could write 5.905 times 10 to the power of minus 3. Now you can see that this is four significant figures. So if I wanted to write this in terms of three significant figures, then I would round the 5 up. So and I end up with 5.91 times 10 to the power of minus 3. So when we're performing calculations, we also have to consider which significant figures we use in our answers. And the significant figures that we use are based on the numbers that are being put into the calculation. So if I have two numbers that are being multiplied together, such as 23 times 578, then that gives me a number of 13,294. Now, if I were to write this in terms of scientific notation, then I could write this as 1.3 times 10 to the power of 4. So you can see that I use two significant figures in my final answer in terms of scientific notation, 1.3, so that's two numbers that are significant. Similarly, if I was dividing, I could divide 6.244 divided by 1.25. Now I get 4.9952. And if I wanted to use three significant figures, then around 5, and you can see that I have 9 after that, so my number would end up becoming 5.00 as three significant figures. So for the multiplication, we had two significant figures as the least number of significant figures, so my answer was also to two significant figures. And when I was dividing, the least number of significant figures I had was 1.25, so that was 3 significant figures. So my answer was also to 3 significant figures. So when we're adding and subtracting, we do something slightly different. We're looking at the number of decimal places. Say for example, I had a number 3.21 plus 4.1, and this is equal to 7.32. Now you can see that 4.1 has 1 decimal place, so my answer would also be to 1 decimal place. So I'd write my answer as 7.3 rather than 7.32. Similarly, if I was subtracting, if I had 12.367 minus 3.15, this would be equal to 9.217. But if you look at the numbers going into the calculation, the least number of decimal places is 2 decimal places in 3.15. So my answer would also be to 2 decimal places. So my final answer would be 9.22.